We're going to look at recursion in the context of functional programs. There is no iteration within functional programming within Haskell, so that means there's no for loops, there's no while loops. So as an alternative, we use recursion. Now the way recursive functions work is that they call themselves. We're going to look at an example based on the total function that you see here. This does exactly the same thing as the inbuilt sum function within Haskell. I just wanted to distinguish that between the two, which is why I've called it total instead of sum. But you notice here there are two parts to it. There's a base case and there's a general case. So let's have a look at the general case first. Notice we have total on both sides of that equal sign here. So essentially what that means is the total is recursively calling itself, and each time it does that, it takes the head of the list, the first item in our list, so it applies it to a list, takes the first item, and then applies the total function to the tail of that list. It keeps doing that recursively until the list is empty, in which case then the base case is invoked and we set the value to be 0. So that's then we know at that point then to stop the recursion. There's a alternative way of doing this for the general case. You can see in the bottom one here where it splits the head and the tail, but we're going to look at the top one because I think it just makes it a bit more explicit and I think it is a little bit clearer and easier to understand. Let's now trace this code and see how this works. When we break this down, we can really see how the recursive elements work. So we're going to apply our function here, total, to our list 1, 2, 3, 4. So we've got 4 elements in our list. So on the first call to total, what it will do, it'll take the head, which is 1 here, it takes that, and then recursively calls total on the tail of that list, which is 2, 3, and 4. Then it applies total to that list, and you can see then it returns the head, which is now 2, and then the tail of that then total gets applied to the tail, so it gets recursively called again, and we keep going through this. 3 now is taken out as the head, and then total then is applied to just a single element that's left in the list, which is 4. And we do it one more time, and you can see here now 4 has been taken out of our list as the head, and total is applied to the empty list. Now this now invokes the base case, so that total with nothing in there, nothing in our list, will return us 0. And then what we can do then is we can then essentially add up all these values as it recursively goes out back up the recursion chain here, and then it just adds up all those values here. So you can see there's add the 4 to the 0, gives us 4. It'll add 3 to the 4, it'll add the 2 to the 7, and it'll add the 1 to the 9, which will give us a value of 10.